Okay, so let's talk angular velocity. Let's talk arc length. Let's talk sector area. I'm going to start with arc length. I could use, let's see if I can draw kind of a circle. All right, so let's just start from basic principles. We know that the circumference of a circle is 2 pi r. So all we need to know is the radius. Multiply by 2 pi, we get the circumference. So if we want to know a particular part of the circumference, then really that's a proportional reasoning problem, because we draw the center here, right? We go from here and say here, and let's say this is, I don't know, 100 degrees. Well, it's just a part of the larger circumference, and we can use, say, 100 degrees out of 360 degrees to be equal to question mark over 2 pi r. So again, we have this kind of a proportional reasoning way of solving this problem. Now, what we're going to develop here is an arc length formula based on an angle measure in radians. And we've talked a little bit about conversions from degrees to radians. And so let's talk about, so first of all, solving this problem, right? 100 degrees times 2 pi r, let's say the radius is 5 inches, right? So then it would just be 100 over 360 equals question mark over 2 times pi times 5. And multiply diagonally, divide by the other number. And we end up with 8.73 inches. So let's back up and do this more generally, leaving this as an angle theta and leaving that as an angle, as a radius r. So if this is an angle theta, we use Greek letters for our angle measurements traditionally. So I'm still thinking in terms of degrees because I got this as theta over 360. Then it's going to be 2 pi r theta equals 360 times the arc length, and we'll call the arc length S. Right, so then I'm dividing by 360, so 2 pi r theta over 360 equals S. So this formula cleans up quite a bit if we think about it in terms of radians, because remember that the way we convert, so let's say we have 40 degrees and we want to convert that into radians. Well, we take our degrees, 180 degrees, and we got pi radians. So then we get the simplification there, degrees cancels, and I end up with 4/18 pi radians. And of course, that can be simplified to 2/9 pi radians. Now, the key here is that if we kind of move these variables around a little bit, 2 pi theta over 360 times r equals S. This 2 pi theta over 360, this is actually just the angle measure in radians. Because if we have an angle theta and we multiply by pi over 180, this is theta in degrees, then pi theta over 180, simplify, is equal to the radian measure. So that's the simplified version of this formula, which is that the S, the arc length, equals R times theta, where theta is in radians. As long as the angle is in radians, we can just multiply by the radius, and that gives us the arc length. Very simple formula. If the angle is given to us not in radians, we could set up a proportion to solve it, or we can just convert it into radians and then multiply by the radius, and bam, we got ourselves the arc length. Okay, so let's take a look at the next problem up, which is essentially similar. That was arc length. This is sector area. Sector area is the same principle. We have a circle. We know that the area of the circle is given by the formula pi r squared. If we wanted to find a particular sector that is not the whole thing, we can just say, what's the angle measurement? And we can set up a proportional reasoning problem to figure out what that is. So again, theta over 360 equals the area of the sector divided by pi r squared, right? This is for the full circle, and this is for the part. So solving for A, we've got theta pi r squared over 360 equals A. And again, if we kind of parse out that theta pi over 180 piece, that's the degrees converted into radians. And so what's going to be left there is theta pi 180 times r squared over 2. This piece is just the angle measurement in radians. So that leads us to our formula. We can use a different angle here. The area, the sector area, is just the angle times r squared divided by 2, where alpha has to be in radians. Okay. So I think a good practice problem is some kind of a composite drawing. Let me just draw something real quick. Say we have that, and let's say we've got this part of a circle on top. Okay, forgive my drawing. So this is part of a circle. Let's say this is 50 degrees, and let's say this is 10 feet, and let's say this is 8 feet. And your job is to, number one, find the perimeter. Remember, perimeter is the distance around the shape. Number two, find the area. So take a minute, see what you can come up with. These are separate problems, so you want to kind of organize them separately in your book, in your notebook, and think about if you're getting stuck somewhere, think about problem solving. You know, what do I need to attack? What's the thing that's getting in my way? Perimeter is just going to be the distance around the shape. So I need basically to add all of these pieces up. And the area is just going to be the sum of the two shapes. So I need to find the area of that. I need to find the area of that. So you're breaking the problem down into parts, thinking about what you know and what you don't know. Go ahead and press pause. And when you come back, we'll talk about the perimeter, then we'll talk about the area. I would say let's round to the hundredths. Take a look. My calculator here. So we'll start with the perimeter. I'm going to break the problem down. So first thing we need is we basically have 5 sides, right? 1, 2, 3, 4, 5. And some of these are easy. They're given to us, like side 2 and side 3 given to us directly. Then some of them require a little more thinking, like Side 1, of course, is directly across from side 3. So 8, 10, 10. This is not part of the perimeter, so don't add this in. But this is important because it's directly across from the 8. That must be 8, which means the radius of the circle is 8, which means this side is 8. So now all we have to do is get this little length here. Okay, I'm going to use the arc length formula. S equals r theta. Theta equals 50 degrees. I need to convert. So multiply by pi over 180. And so we're looking at 5/18 pi as my angle. So R we agreed was 8. So the arc length is just going to be 8 times 5/18 pi. So that's what I'm adding in. I could simplify this out a little bit. 4/9, 29 pi. Looks like my answer. I'm ready to add it up and do my rounding in the end. It is important that you can sort of think exactly as well as approximately. When you go to calculus, there will be plenty of situations where you're kind of forced to give the answer exactly, and often that'll be in terms of pi if you're talking about geometric problems. So I'm looking at 42.98 as my perimeter. That's feet, 42.98 feet. Okay, let's take a look at the second part. Get rid of the stuff that I don't need. I love the fact that this eraser is so exact. Okay, area. So part 1, part 2, we need to find the rectangle area. We need to find the sector area. Big part of success in mathematics is organizations. You see, just really laying out everything on paper. Clearly 8 by 10 is my rectangle. That's 80 square feet, not feet. And then I need to find the sector area. The sector area, remember, is 1/2 theta r squared, where theta or alpha or whatever is the radian measure. We already did the radian measure, but I'm gonna do it again. So theta, we got 50 degrees, but we're gonna convert it. That's pi over 180. Cancel, cancel, strip off a 0. That's a factor of 10. So it's 5/18 pi. So here's my formula. 1/2 5/18 pi times 8 squared. So the radius was 8. So we've got 8 times 8, 64, divided by 2 is 32. 32 times 5. Well, let's simplify the 32. All right, sorry, I'm doing a lot in my head here. 5/18 pi. Simplify 16/9. So this is looking like 80/9 pi. So basically I've got 80 square feet for the rectangle and 80/9 pi square feet for the sector. So I just add them together, and again, we'll come up with our estimate. The nearest hundredth. It's like 107.93 square feet is my best answer. I think it's always useful when you're thinking about these problems to kind of mentally judge, you know, if you type something wrong in the calculator, right? So 80 is obvious. This number is not obvious. So I'm mentally kind of thinking 80 divided by 9. Well, that's like 81 divided by 9. That's 9 and pi 3, 9 times 3, 27. So yeah, 27 and 80, 107. This is in the right ballpark. So my calculator, you know, I've not entered something in wrong or done something crazy in my calculator. Okay, so last problem in this set is the last type of problem in this set is looking at angular velocity. So again, angular velocity has a formula. V equals r omega. Omega is the angular angular speed, r is the radius, and v is the linear velocity. Linear just means what is it in a straight line, right? So if you think about something going down the road, let's say a bike, the wheel is spinning, and the wheel is spinning as the bike zooms ahead. So we can think of the velocity here in two ways. One, how fast are we moving forward? And number two, what's happening as we go around, right? And of course, the connector there is the circumference, because every time I do a rotation, which is 2 pi radians, I've gone one circumference, which is 2 pi r. So let's take a look at a problem that you would have for this type of situation. I already wrote a problem. I'm going to bring it over and we'll talk about it here. Okay, so you got a cyclist zooming down the road at 35 miles an hour. His wheels are 26 inches in diameter, and find the angular velocity of his tires in radians per second. So the angular speed is always measured in radians per unit time. The unit of time is going to be determined by this side of the equation, the linear velocity. So one of the things I need to notice about this situation is I've got a mismatch between my units of time. Here are hours, but I want to have them in seconds. I also have a mismatch in terms of the distance, because this is in miles and this is in inches. I made a separate video for conversions to talk about exactly this type of situation, but I'm going to go through this problem. One of the ways that you can solve it, I would recommend doing that conversion work first instead of just doing, v divided by r equals omega. This is true, and this is how I'm going to basically solve the problem. But I really need to do, it's not 35 divided by 26. So I got multiple things going on in terms of conversions. Also, be careful here because this is a diameter, not a radius. All right, if you want to take a stab at it, go ahead and press pause, and then we'll jump into it. I don't really want to erase the thing that I've written all over it. Maybe I'll use my selector tool to move it off. There we go. Okay. So we've got V equals 35 miles for every 1 hour. So my first step is going to be do a conversion here. I want to get this in inches and I want to get it in seconds. So I'm going to change my miles into feet, change my feet into inches, and I'm going to change my hours into minutes and my minutes into seconds. So I've got 1 mile, 5,280 feet. I've got 1 foot, 12 inches. I've got 1 hour, 60 minutes. I've got 1 minute, 60 seconds. So I've set up my conversion now, and I can check my crossouts. Inches is going to stay, hours, minutes. Okay, great. So basically I've converted now. This it's going to be 35 times 5,280 times 12, but I'm going to divide it by 60 by 60. So I end up with a velocity of 301. This is 301 inches per second. Last thing to do, the diameter is equal to 2r. So of course I'll just divide by 2. The radius here would be 13 inches, and I'm ready. V equals r omega. So V divided by r equals omega. So 301 inches per second divided by 13 inches gives me my radians per second, which is 23.15. Okay. So when you're solving these types of problems, you may be asked a question where the linear velocity is missing. You may be asked if the angular velocity is missing. So you got to be able to kind of be flexible in terms of what's being asked and how you're going to approach it. Also, it's worth mentioning that if the problem says something about rotations, that one rotation is equal to 2 pi, right? 2 pi radians, because that's a full circle basically. So a lot of times the rotation will be discussed, like I'm in a Ferris wheel and I went around and I did 4 loops around before I got off the Ferris wheel. Well, that's 4 rotations, and that can be converted into radians, which is 8 pi radians. Okay, so that's the basics of arc length, sector area, and angular velocity. Lots to practice and think about there, but that's what you need to know.